check out this beautiful modern staircase. Now, every builder has a stair guy in their back pocket, but can your stair guy do this? Man, this is a gorgeous setup. Now, the build show's on the road. We're actually in Goshen, Indiana, where this staircase was manufactured. This is a ViewRail flight stair. And if you're not familiar with these guys, they manufacture the entire process. So from the hardware to the steel stringers, the wood treads, the handrail, the glass, everything comes from ViewRail. And these guys have a brand new install program where they can send their people out to measure at the rough stage, and then their crew will come back with your beautiful staircase and install it sometimes in as fast as 1 day. We got a great video for you today, guys. We're gonna go through the entire process, including pricing, how they're fabricated. I'm gonna live out my how it's made fantasy at their manufacturing facility, and we're gonna get into the install process as well. Today's video is sponsored by ViewRail. Let's get going. All right, guys, I've got with me the founder of ViewRail and the owner of the company, Len. Lots happened in 2 years since I was here last, and last time I was here, I got to watch a 1-day install on a ViewRail flight like this. What's changed in the last 2 years?
Welcome back, Matt. And right now you're in our new training center, because when you saw us before, we were shipping product out to builders and encouraging them and showing them how they can do a 1-day install. We've taken that to the logical conclusion, and we now have a national installation program.
Wow.
Yeah, so it begins, you contact us, you're talking to one of our salespeople, we're gonna give you a price on the stairway, so you know what it is, what the installation is gonna cost before you even go on.
Okay, so this entire stairwell here, you could give me a price and a rough quote before we do anything.
Matt, I'm not gonna give you a rough quote, I'm gonna give you the number.
Okay.
You're gonna know what it is.
Love it.
Before we ever go past go. And then once you've agreed to that, we're gonna send a team out to do a measure of the space. And so when they come out and measure the space, they're gonna be looking at a lot of things, especially like what are the site conditions for attachment, because that's really important. We wanna make sure that the blocking is there, that's correct. And we're grabbing more than just a floor-to-floor measurement. We're grabbing a floor-to-floor measurement. We're shooting a laser over there because we're really concerned about how level this floor is.
That's right, that floor was going down. That's going to change. And as you know, all those stair codes are pretty finicky.
It's really tight, especially on a U-shaped stairs like what we have here in the training center. And we're going to be looking at headroom, looking at code compliance, and getting all of that done. And here's the beauty of it, Matt. We're sending someone out there to do a measure. They're interacting with our engineering team. They're going to turn around on their iPad and be able to show you a full render of your system before they ever leave.
That's pretty cool. Now, on a remodel situation, which this kind of mocks up, you might want your staircase, pretty quick. If you're on a new build like I often do, and maybe a few months, what's it take from that measure until you're ready to install a stair like this?
So from the time we've done the measure, we have a little bit of interlude there as you finalize finishes and you're really sure we've got all the finishes you want. You give us the contract, we say go, and we're gonna be on your job site in 3 weeks, maybe 4 weeks, depending on the schedule.
Dang, so you're gonna install this maybe 3 or 4 weeks from the measure date.
Exactly.
That's amazing.
Yeah.
That's
now, if you're having
cool.
new construction, we may need a longer phase,
Right.
and we can get that scheduled into what your new construction schedule looks like.
Yeah, so you may come in and measure, not in this situation that you're mocking up here, but in the rough, where all the structure is exposed. We can verify everything in terms of structure, and then we're gonna come back later in the process. Len, last time I was here, I got a shop tour. I'm really excited to see what you guys have done different, because you're making all of these parts we're seeing here, right?
Everything you see, from the steel stringer to the bent brackets, the lumber, the posts, the handrail, the glass infill, and all the hardware that brings it all together. Let's go take a look.
Oh man, I'm excited. Let's go see the shop, guys. Len, this is cool, man. What is going on here?
Matt, all of our products are engineered to order. And so when our engineers have created the design for the stairway, that data is fed into this machine setup. It's first going through the saw where it's cutting it to length. It's feeding it along here. This is a laser etcher, and this etch is giving a 3D code so that it can be scanned and put into any of our machines to be able to precisely put the holes where they're going to need to be for the rod railing, cable railing, glass railing, or whatever railing we come up with next.
So this is instructions on this particular post for what the machine needs to do to this post.
So this instruction is not only for the post, but this is job specific, location on a job specific. Everything is made to order in a one-piece flow.
So that's why that measurement that's happening out in the field is so critical, because every part and piece here has a location and a piece.
Exactly.
All right, so then what's next, Len?
So as it's coming along here, it is machined in one of these 3 machines we see here. They're scanning it, the cycle is running, and these are primarily for straight. And then we have a really fantastic Perco machine over here, which is able to drill the holes at an angle. The head dumps to the left or to the right, so that in the cable or the rod railing, we have an angled hole through the aluminum.
Oh man, that's awesome. This is some impressive stuff. What's next in the process, Len?
It's got to keep on going down and everything has to be matched up. So now we need to put a foot onto the bottom of it and press the top in. So those are the next machines we'll see down here.
Let's go have a look.
Matt, next stop in this process of this engineered to order is making sure that we get the right configuration of the bottom flange and the top.
Okay.
And so right here at this station, we are scanning and it's bringing up to the operator visual representations of what to do next in his operational flow. So the top is dot peened so that it can continue to match through. The press is pressing that into this, and we have some go, no-go fault testing to measure the press force, and that is our quality assurance method to make sure that we're meeting the quality spec that our engineers have called out.
Oh, that's cool, because it's hollow tube, so you're basically capping that tube right now.
Yeah. And Matt, I know you're strong, but you're not pulling it out of there.
I can't imagine you are. That's cool.
Next step down the line here is going to be the welding phase.
Okay, so then this is going down the line, and then this machine does the welding for you?
So this is a MIG robot welding system, which is able to weld any of the posts in any of the different configurations and hold a very tight quality assurance path. Those are 2 of them that are set up in tandem to be able to keep up with the flow of operation.
Oh my gosh, so you've got one here and one here. And then after the post's done, what's he doing here?
He's doing a scan, and that scan is feeding back to the database to say, I have a complete assembly, I'm done with the fabrication, and now we need to apply the color to it.
Okay, so from this part on, it's gonna then go to a process that's a powder coating process, or what is it?
Yeah, but any painting process is really about the preparation. And we've really taken a belt and suspenders approach of doing a shot blasting, which I'll show you down here,
Wow.
as well as a cleaning.
All right.
Matt, here's a great example of the engineered to order. So we can see here are holes for rod railing or cable railing come up along here. And notice the transition to different shapes because it's transitioning to a key mount fitting there. And then we have an extra hole here, which is for a handrail bracket. All of that has been engineered and developed.
That's so cool. And then this is that cap that got pressed on.
Correct.
And then did that also get touched up? It looks like it's been...
just a little touch up to blend that. And now this is before the shot blasting process, which the shot blasting will put a mechanical etch on the outside of this so the powder coat can really have something great to bite onto. And the shot blast also evens out any of the imperfections and rounds over all of the edges. Paint hates a sharp edge. Yeah. So let's open it up. We'll take a look at what they look like when they come out of the shot blaster.
Okay, let's do it, Len. Oh man, look at that. That is cool. I've never seen an industrial shot blaster before. What's the blaster material here, Len?
So right here, Matt, go ahead and grab a
this?
handful. This is a stainless steel shot.
Oh my
And
gosh.
we've had to experiment with different sizes and textures and shapes. And this is what we found gives us the right edge.
It's really fine. And look at that post. That's gorgeous. And man, that's almost a finish of its own. That looks really nice. And look how evenly it even finished over top of your weld too, Len.
Rub your fingers across there. You can feel the etch.
It's got a little tooth to it, which is good. Paint's gonna bite on there, right?
It's gonna want to hold on to, yeah.
Yep. Okay, so then after this, what happens?
Let's go look at the Immersion 5-stage washing process.
Okay.
So next is the washing process. It's a full immersion, so we're cleaning the inside and the outside. It's a alkaline wash where we are dipping it into this tank that's running around 130 degrees.
Okay.
And it's in there for about 2.5 minutes. And then it steps through each of the other tanks. And one of them is a zirconium rust inhibiting or corrosion inhibiting compound that we're putting on that is prior to the powder coating.
Interesting. So it's just rotating around and dropping in each one of those tanks.
Exactly.
Got it.
Matt, next step in the process is going through the drying oven. And in the drying oven, we're going to heat the aluminum, and then we're also going to cool the aluminum. And that is going to allow for outgassing of any trapped gas that's inside of the aluminum so it doesn't come out later in the curing process.
After the finish is on, which would cause a problem.
Exactly.
Got it. And so then after it's dry and ready, what type of paint process are you using?
It's a powder coating process, and we have 2 levels of powder coat for the extreme coastal and then for typical use.
Oh, I can't wait to see that. Is that next up at the tour?
That's next.
All right, we'll meet you there. Oh man, look at this beautiful paint booth. Wow. All right, Len, I would suspect this is hard for you guys because, as a custom builder, I've got, a million different colors and every house is different. Every room might be different. Talk to me about that process for you guys.
Matt, over here in these hoppers, we have all of the different color options that we have for the market.
Okay.
And we have a quick change system where in 30 seconds, we can change from one color to the next.
Wow, that's pretty quick. Because every job that goes through here is going to get a different color, probably, right?
A lot of our customers are choosing a lot of custom colors to complement their house, but it's still 80% black.
Is that right?
Yeah.
That's funny. I can see that. That's great. All right, so then the line brings the posts in, and then how's that powder coating process work as it comes through?
Well, this room doesn't just feel good for no reason. This is an environmentally controlled room where we're controlling the temperature and the humidity year-round for storage of our powder as well as the application of the powder. Because those factors are really important to get the adhesion that we want and the finish that we want on all of our powder coats.
Okay, so that's why the massive HVAC system I'm seeing here with 1 million vents going on.
Exactly.
And then as the post comes in, if I understand powder coating correctly, basically the post is kind of like a magnet for the paint to stick to, is that right?
Correct. There's an electrostatic charge, so as the post is hung on the conveyor, that is making the ground, and we're positively charging the powder, and so it's wanting to adhere to the post.
And then where's that baked on process happen? In this oven right here?
This is just an application booth, and then it is going to continue on through these windows, and it's going to go into the curing oven, where it's in the curing oven for a specific cycle time.
Okay, and that's what's actually baking that finish on.
Exactly.
Got it. All right. All right, Len, so the finished product right here, beautiful.
We've taken a lot of care to get it to this point, all of the washing and the powder coating and the curing. Now we're going to make sure that it gets to you in the right order and gets to you in a safe manner. And so here's the packaging system. So she's scanning it there, and that's the final scan from the beginning of the manufacturing process, which is going to generate a label through the database, as well as mark this order complete in our system so we know it's all done.
That's so cool.
Yeah. So my background is with stairsupplies.com, and we started the website with primarily wood and iron balusters. So
and that was 20 years ago, right?
Yeah, about 20 years ago. My heart really is in woodworking.
Man, so talk to me about this robot that's back here, Len.
So a big part of our philosophy is using automation to unleash the imagination of our craftsmen. And so this robot really works alongside of the craftsmen and doing about 70% of the sanding work, so they can really focus on the fine details while this is taking care of the coarse work for them.
The heavy lifting, so to speak.
Exactly.
Now that lumber on that stair tread though, how did that come to you? Is that rough sawn lumber that then you guys are taking and turning it into this tread that we're seeing here?
So Matt, we have a relationship all the way back to the source. So the person who's cutting the tree down, we have a relationship from there all the way through the milling, the drying, and so we're getting lumber that has been kiln dried and is ready for processing. I can show you that over there if you'd like.
Let's do it. Len, check out that beautiful stack of rough sawn lumber. What's the process to take it from that into a stair part?
Well, begin back in that engineering and the measurement, and that data is then fed into the database. The database is manipulating it, creating a cut list, feeding it into the saw. The saw operator is then telling the forklift operator, hey, go get me this pack of lumber. And we're feeding it into the saw to be able to utilize the resource to the best of our ability. The blades are moving, lasers are reading the width and the character of the board so we can use it to its utmost.
So we're ripping, and then we're planing, and then we're sanding and making parts?
You just about got the order right. We're gonna rip it, and then we're gonna chop it. We're gonna sort it into the correct usage. Then we're gonna plane it, we're gonna glue it, we're gonna plane it again, we're gonna sand it again, we're gonna mill it, and then we're gonna sand it again.
Yeah.
A lot of steps.
It's a really cool operation, Len.
Yeah. I know we got an order going through right now for one of your houses. This might be it right here. This white oak thick stair treads. They're gonna go through this planing process where we're getting them dead flat. And that dead flat's hard to do and really important because next is gonna be the gluing process where we are gluing them together and turning them into the thick tread that you're looking for. After that, we're going to plane it, sand it, and machine it again.
I thought this process, Len, was so cool because it's part machine, part craftsman, and we do glue ups on the job site all the time. This isn't too dissimilar from that, right?
It's really the same process as what you might do on the job site. We're just able to apply more pressure at exactly where we want it, and we're able to hold it in those clamps for the 2 hours that's required for the glue to set.
That's really cool. So then after that clamp process, let's pick it up next.
So Matt, coming out of the glue rack, what we're looking for is a nice consistent glue line of squeeze out. And this is looking like they did a really good job. We got just the right amount of squeeze out along there. And the next step is we're gonna send it through a two-sided planer. And that's really just to knock a lot of that glue down so that then we can sand it and get a really smooth finish.
And so in this process, you're doing your flight treads, which are the really thick treads, but you're also doing your standard treads as well over here, right?
Exactly.
So fun. I love, as a woodworker, I love seeing this giant machinery making such precision.
So what we're able to do here, Matt, while we're running this thick tread, which is a very specific width, we're able to run this random width tread right alongside of it. And our software is looking at how to balance that cut bill to be able to use the resource to the best of the possible ability.
All right, let's keep moving. I love it.
Matt, we have engineered, ripped, chopped, glued, planed, sanded, and now machined this piece of wood to go to the exact position on a exact stairway.
So this can be tread number 4 in a specific job, and everything is in the computer, so it knew and made everything milled precisely for that specific location.
You got it.
That's really cool. What's a machine like this cost? This has got to be a very expensive machine.
Just under 300,000.
Not as much as I thought. We can cut this out if you don't want to put that.
Fine.
That's pretty cool.
When it's my money, it's not that much. The last thing I ought to mention is what we do with our scrap.
Yeah, I was wondering that.
Yeah, we have a large Amish community as well as a large horse racing community around here. And they use a lot of this once it's ground up for animal bedding.
Oh man, white oak animal bedding, that's nice.
I've showed you the sanding robot and the hand sanding operation. And in here, this is the finish booth where we're going to apply a custom stain and then a 2-part finishing process to give incredible durability and the look.
Wow. And you've got both ViewRail Flight, which is your fairly modern line, but you've also got some traditional stair parts as well. I love seeing that.
Yeah, the traditional stair parts, box nulls is where we cut our teeth. I really believe that our box nulls we build are some of the best in the industry. And we love the Flight thick treads as well.
Yeah, I do too.
So notice this is a sprayed on stain and now it is hand wiped. This is a pretty involved operation where there's a lot of labor and there's a lot of skill. These guys are doing more than just wiping a rag on there. They're looking at really blending and making sure that all the lines and the look is just right.
That's gorgeous. I love that there's such a high tech, and yet there's that craftsman touch on these parts as well, Len.
The stain application is really important, but what people are going to touch and feel is going to be the sealer and then this top coat. You feel how glassy smooth that is?
Man, that feels really good.
That's the kind of finish we can achieve in this controlled environment. We've got infrared lights to be able to kick off the finish and really control all of the curing. It's a really important piece of getting the finish that you're after.
And I like that it doesn't look plasticky. We can still see the grain through there. You can tell that it's wood and not a printed on finish, right?
Exactly.
And tell me about that. That looks super trendy right now. Those grays are super hot.
Yeah, achieving this isn't as easy as might appear. This is an ash tread, and so we've got the wonderful grain of the ash here on the face. And then this finish is a combination of a stain and a glaze to be able to get that gray look, which I know you're after right now.
Yeah, for sure. And talk to me about the infrared lights, right?
Yeah, so we built ourselves a little infrared tunnel here, and this helps to give a quick cure to the finish so that we can handle it a little more quickly and be able to get it well cured before we put it into a package and we ship it out for your house.
Man, what a tour. Did we miss anything in the shop today, Len? I know there's a lot to talk about here.
There's a lot to talk about here, but I think you've seen the highlights.
Man, beautiful. Last thing I want to mention, Len, you guys have, it looks like a kind of a custom shop that's doing all those traditional parts. And I think it's so cool that you've got the ViewRail flight system, which is totally the modern house. You've nailed those details. But yeah, you've all those traditional stair parts as well. It's fun to see both in one shop.
We really enjoy the diversification. It's good for our business, it's good for our customers.
Love it.
Matt, I showed you the wood and the larger aluminum parts. This facility is all about making the hardware and the fasteners and the attachment points for things that about the size of what fit in your hand.
So you're making all those parts and pieces down to these small ones as well.
Exactly. Our aim is to control the entire process.
Very cool. Graham, will you fire up this machine for us? We want to see how these are made. So Len, talk me through this. This is obviously a 5-axis CNC. You've got a billet of aluminum in there. What's about to happen here?
Correct. So there's a big billet of aluminum in there, and we're going to get on it pretty hard with this cutter and turn this into a talon, which is a part for grabbing a hold of glass. So we start out kind of polite, getting it to the nice shape, and now we'll dump this head over, and we're going to start getting on it.
Is that a carbide tipped blade like you would see in woodworking, Len?
You know, it is a carbide tipped insert tool, but it's going to be a different angle and a different geometry and design because it's made for aluminum.
Okay.
You see we're throwing those chips around, and it's a cycle time of close to 8 minutes to be able to make this entire part.
Okay, so it takes a while.
It does take some time.
In this facility, you've got a lot of cable rail and rod systems as well. Are you making all those parts as well here?
Yeah, I'm guessing there are around 100 different components that are being manufactured in here, and they are running from 4 a.m. to about 8 or 9 p.m. every evening.
Oh man, so just like in the wood shop, raw wood comes in this case, billets of aluminum come in and all those parts come out.
You got it. Billets of aluminum, rounds of aluminum, as well as a lot of stainless steel.
Man, you guys do it all. Pretty cool. Let's see the next stop on the tour, Len.
Let's go. We are really committed to making all of our own fittings for everything, especially our rod railing and our cable railing system. So this piece right here, this is the quality that you're going to be looking for from this finished quality on this 316 stainless, the exact way that the threads are made, and we're controlling that by making them here on these Swiss machining centers. There are 15 of these machining centers. They're coming in at 4 a.m. every day, setting them up. They're running till 4 p.m., letting the machines continue to run while people go home, starting again the next day, so they can make about 75,000 of these a week.
Oh my gosh, wow. And so all those milling operations are happening behind here. Is that a cooling oil that I'm seeing being sprayed in there?
So the oil that is running through there is a mineral oil that's performing a lot of functions. There's a lot of lubricity there, and we're monitoring that lubricity as time goes on, as well as it's evacuating chips and it's providing cooling.
Man, 75,000 of those tiny little parts every day in stainless.
It's a lot of parts.
That is pretty cool.
Let me show you how we keep them organized.
All right, let's do it.
Matt, I showed you how all those cable railing and hardware pieces are made, but that's really only half the battle. Now we got to get them counted and get the right amount onto your job site. And so that's what we're doing here. This machine is counting, bagging, and labeling. And then at the bottom here, there's a very precise weigh checker. It's checking the weight to make sure there's exact right count in every bag. So it's a two-step process to make sure that you're gonna have what you need every time.
That is wild, Len. I want to point out that there's been so many parts that have gone through there that the powder coating has worn off on the black plate because so many things have hit it over the years. 75,000 parts a day.
And that weigh checker is so precise that we have to recalibrate it every now and then because of wear of the paint.
Wow, that's pretty neat. That's cool. And then how do these parts then go with the other parts that get shipped out?
Let me show you that.
All right, let's go. All right, Len, 75,000 parts that have now been bagged. How do you get these correctly into the box that comes to my job site?
Matt, we've been in business 20 years. This is hard.
I bet.
This has been really difficult for us. We've struggled at times, and so we had to commit ourselves to an absolute two-step verification on everything we do. So the way it works is you send us in an order, goes through the order process, it's sent out here to the floor. We're gonna scan a tag, and that's gonna start the whole sequence of events in order. And that sequence is gonna begin with all these lights start flashing. And what that means for this order number, the operator needs to go and pull 6 of these bags. Pull 6 of these out. They're gonna hit the button saying, yep, I've completed that order.
And this one's not flashing, so I don't need anything from that bin for that order.
Don't touch it. If it's not flashing, don't touch it. Wow. And now the two-step part, we move up here, which is kind of the grocery store checkout kind of thing.
Okay.
And so every bag is going to get scanned, and if we scan it and it wasn't on the order, it's gonna make some really bad sounds at us, telling, hey, you did something wrong, dummy.
Got it.
And when the order is complete, it won't let us scan anymore, and it won't let us close out the order until we have scanned the complete number, seal it up with tape, UPS labels on it, and it's coming to you tomorrow.
That is really cool, and I think the Japanese call this the Kanban system. Is that correct?
Yeah, Kanban is a signal, means replenishment, and so we are replenishing just across the wall to where you saw the parts being manufactured.
So you're in a just-in-time system where you're not making a million parts, you're just making the parts you need for those orders coming up.
If we don't have a signal for an order, we're not making a part.
Man, this is an impressive operation, Len. I think this is my favorite part of what I've seen so far today. Even though I'm a wood guy, this level of organization and precision, very, very impressive.
Our people have done an incredible job. I'm really proud of this, Matt.
All right, what's the next, bud?
Well, let's go see how all of the orders come together. When you have a big order for a big stairway, we've got parts coming from all different plants, how we're gonna bring it together, get it on a truck, get it to you undamaged.
All right, let's go.
This is the last step in the process that we do. So parts are coming from our various manufacturing facilities, all within a mile of this shipping hub. And we're verifying that everything is complete, everything is labeled and documented correctly. And then we're sending it out either R&L carriers, UPS, FedEx, small package, or if it's an install job, it's going to go on our own truck to be able to go out to the install site.
That's incredible. So in these boxes we've got here, you've got some glass, you've got wood, you've got stainless. Everything basically comes here and then gets shipped out from there.
Exactly.
Very cool.
Welcome to our metal fabrication facility.
Now I was here 2 years ago, Len, but this looks totally different.
We tend to change it up. Our growth rate is requiring us to shuffle machines and people. So we need people who are pretty flexible, and that's what we've got here.
And I've never seen a machine like this. What is this thing?
So this is a fiber laser. We're bringing in sheets of stainless, aluminum, mild steel, and we're putting them onto the fiber laser. That engineered to order thing, right? It is dropping files out of our design system, out of the CAD, and dropping them right onto this machine, and it's cutting the steel or the stainless or the aluminum with a laser, and then we're able to pull those parts out and bend them up and make a beautiful stairway for you.
So a laser cutter, I'm assuming that's much more precise than like a plasma cutter that I would think of, right?
Right. The laser is shooting a lot more power in a very finely controlled beam. And we spend a lot of time setting this up to make sure that laser beam is perfect for the cut.
And where does the name fiber come on a fiber laser?
So there are several different laser technologies, and I'm not an expert on them, but I know what works for us. And a CO2 is a little older technology, and a CO2 laser is what we have down there. This is the newer generation fiber, where the power from the diodes is traveling through a fiber optic cable and going right over to that nozzle.
What?
And that's how the power travels. In the old CO2 technology, they actually had mirrors. And so the laser is bouncing around and it's controlled by mirrors.
And this is a fiber optic cable.
Fiber optic cable, yep.
Okay, and then these parts on the bin over here, can we walk over here and
Sure.
see this? These were once flat stock that came off the laser, and then I'm assuming this is getting bent into the shape that it needs to go then?
Sure, we have a couple of press brakes here, and we run different programs based upon the angle of the stair, and we're able to bend the parts from a flat into that shape, and then once that shape is created, they're going to go into the weld cell.
That's what's happening here.
You hear it in the background
I can
there. The weld cell is doing a little bit of welding on there so that now we have the
There it
finished
is.
part.
That's cool. And that shield is down, so we're not seeing that laser and getting burnt in our eyeballs. But then that part is hot. But that's fully, at this point, it's fully done. It's ready for some finishing, right? Or you gotta do the same process like we saw in the railing parts.
Yeah, same everything as what you've seen before. It's going to come out. It's going to get the shot blasting. It's going to get a little bit of cleanup, and it's going to be powder coated.
Yeah, but this is all mild steel, I'm assuming, right?
Correct. This is mild steel.
Because this is your structure of the rails.
Exactly. That's what all of our engineering documentation is come up with these sizes and these shapes and these controls to do that.
Very cool, man. Len, this center stringer is definitely the hallmark of your flight system. I'm guessing there's a fair amount of thought that went into these bolts and everything that happened to get it to this position.
This is a pretty far evolution from where we began when we started doing the stringers.
I can imagine.
And there's a lot of detail in here, and I don't want to get too lost in it, but every hole is placed precisely where it needs to be to have the right angle, to have the right rise and right run for the specific job. So these aren't just cookie cutter. The spacing is special. And what's really unique about this hole, it is a friction drilled hole or a flow drilled hole.
Huh. What does that mean? I'm not familiar with that term.
Yeah, we're taking a special tungsten carbide cone, spinning it, producing a bunch of heat, and we're actually moving the metal. We're not removing, we're not drilling it, we're moving the metal in there, and it produces a flange inside of here. So then when we come back in with a tap, we have about a 1/2 of an inch of flange to be able to get the threads. So this is a half 13 with a 1/2 of an inch of engagement out of only a 3/16 inch wall tube.
So the 3/16 wall is basically almost like stretched. So you've got a much deeper thread you can see those kind of nipples sticking down into there.
Exactly.
And then later you're coming back with a tap to give us the threads.
Correct. Yep.
Wow, that is awesome. And then what's next after this step?
So after this, it's going to get some grinding and some cleaning up of these flanges. And then there's going to be some connection plates that are going to be added to each of the ends so that when you get it on job site, it's fairly lightweight because we've stripped a lot of the assembly portion off. So it's easy for you to carry into the job or for our installers to get into the job. They're going to bolt the plates on it and be able to install it.
How heavy is a stringer like this typically, Len?
I'm going to peg this one at probably 140 pounds.
It's not that bad, really, in the scheme of things.
Yeah.
For as much weight as it's carrying and that load, 140 pounds. So 2 guys can carry that on the job, no problem.
Certainly less than your refrigerator.
That's for sure. All right, guys, next up, glass. Now, Len, this is a pain point for me as a builder, and I'm so glad you guys are now supplying glass, because as a builder, I'm often measuring and waiting weeks and weeks for glass to arrive on my job site. It just slows my jobs down. Talk to me about your glass manufacturing here.
Matt, we found it's a pain point for a lot of builders. And so we really knew that we needed to get into our CAD model, the glass design, and we needed to be able to kick out a complete stairway with not just treads in the stringer, but also the glass. And it is drilled, cut, polished, and tempered, ready to be installed.
Man, that's awesome. And that's glass that's on an angle sometimes going up the stairs. Sometimes that's for a channel set guardrail, right? That's all that sort of glass.
It is all of it. There's a lot of just balcony glass, there's guardrail glass, there's barrier glass, and obviously there's a lot of stair work.
Now walk me through that process, because I'm assuming, Len, that's not an easy process, and you have to probably send this somewhere to get tempered too before it goes to the jobs as well.
Matt, we're doing it all right here.
Oh, wow.
Large sheets of glass, which you can see behind you, they're coming in from the manufacturer of the glass, what comes out on a float.
Okay.
And we're bringing in these packs, handling it, and we're cutting it with this cutter where the download is coming from our CAD files to optimize the usage of the glass, to cut it to shape. We're going to break it, and then we're going to polish it, put any holes or cut any other features that need to be for the mounting system. And then the washing is super critical. It's going to get the glass really clean, because we're going to heat it up to 1600 degrees. Ooh. And then we're going to cool it down, and that's what's going to give it the temper.
Got it. So that high heat is that tempering process. Now, Len,
Matt, if I can correct you a second, the cooling down is what really does it. It's not just the high heat.
Okay,
but we have
got to go from hot to cold.
To hot to cold, that's the magic.
Got it. Now, Len, when I look at this sheet of glass right here, I'm not seeing any of that greenish tint that I sometimes see, and I know that's a pain point for architects. Talk to me about the grade of glass that you're using.
So we made a decision, and this is a pretty strategic business decision, for us to only use low iron glass. Now the green that you have seen in glass in the past, you're not going to get from us. It's going to be the blue.
Okay.
The green comes from the iron content from the sand, because glass is primarily silica sand.
Yep.
So we are sourcing glass that is made from low iron content. So there's certain glass, a certain sand around the world that has a very low iron content, and that's what we're using to give us the blue hue. It's the only thing we allow in our building.
Okay. Now, when my grandfather made stained glass when I was a kid, he had a carbide cutter that he would kind of strike the glass with, and then it would pop off. Is that similar to what's happening on this giant air table you got here?
Well, my grandfather had a carbide cutter as well, and I can remember doing that process. We've taken it a little bit further. We have a carbide cutter here, and it is being controlled the pressure. We're also choosing the correct angle of that carbide cutter, because the angle makes a big difference in how the glass is going to break. Okay. So we really just put a score in it, and then it moves to the break table.
Okay, and that break table, I'm assuming, is changing the angle of the glass and doing just like we would do if it was a small piece, exactly. Except that's giant half-inch thick pieces of glass.
We're just using the weight of the glass itself, and by lifting on the score line, the weight of the glass itself will give us a nice clean break.
And then talk to me about the next process, because probably that big machine down there is doing your drilling, any other operations that need to happen on the glass. Is that right?
So actually, as we walk through here, this machine right behind us is doing the edge polish.
Okay.
So when the glass comes out, it is raw, and the edges are incredibly sharp. They're very dangerous. And so before we can get it to the customer, we need to get a nice polish on the edge. So it's a multi-wheel polish process to get the glass looking really nice.
Got it. So kind of sanding for glass, basically, right?
It really is. Yeah, we're just starting with coarse and working to fine. And the management of those wheels and the management of the water that we use to keep it clean is a big important piece.
And then what's the next big machine that I'm seeing down here, Len?
Shapes that we can't cut or break that are going to have to be milled go on to the CNC machine. And so this can actually mill out glass with a special diamond cutting tool to be able to get the glass shape if we have certain shapes that are more complex.
Wow, that's wild. I didn't know there was such a thing for glass. That's crazy. And then after it comes out of here, then what's this next process?
Yeah, so here we're washing the glass, and this is just very clean RO water, just like you're gonna put an RO system in your house.
Oh, yeah, okay.
We have a little bigger
so
one
there's
here.
No spotting, basically.
Right, and so there's some brushes, a little bit of temperature, and we're cleaning up the glass, and we have inspection lights at the end to look for any imperfections before we temper.
Look how dirty that is going in, and look how beautiful it is coming out.
And it's got to be beautiful coming out, because any imperfection in the glass or any dirt would get baked in by the tempering process.
Gotcha. And then Len, talk to me about these two machines that are actually doing the tempering for you.
Yeah, so this was our original oven that we got started with, and we found we outgrew its capacity, and so we installed this much larger tempering furnace over here.
That is a big boy.
It is a very big unit. The glass is going to start on that end. It's going to go in. It's going to get heated up to 1600 degrees Fahrenheit, and we are going to be moving it back and forth. Because if we weren't moving that glass back and forth on rollers, the heat, it would sag and it would puddle.
Oh wow, that's wild. Crazy.
So when it comes out of the heat, it's then going into the blower, and that loud sound we hear in the background is the blower. That's going to give an instant cool to the glass, which is going to give the right temper to it.
And then you're packing it up in these crates and it's heading out to job sites.
Exactly.
Very cool, Len. All right, Len, we're back in the training center after an incredible tour. I really enjoyed seeing your super sophisticated operations. Len, talk to me about pricing. You know, what are we looking at for a ViewRail flight system?
Matt, the flight system, it's going to be typically around 15. It's going to bottom out at around 9.
Okay. And that's including handrails, treads, all that kind of stuff?
Matt, that's going to be for everything for the stairway, the stringer, the treads, the handrail, the infill, whether it's going to be glass or cable or rods, and all the hardware that's going to be needed to put it in as well.
Okay, good deal. And then lastly, Len, talk to me about install. This is new for you guys, right?
It is. We have been doing it for about a year, but we have really taken it to the next level of covering the nation, and we have several of these vehicles and teams that are ready to come out on site, do a measure, and then do an install for you.
That's
or
so cool.
Any builders like you.
So whether you're in Chicago, which is close by, or Texas or Florida, all those states, you could actually do the measure and the install for a builder who maybe didn't want to do that themselves. Is that right?
Exactly.
Very cool. Guys, an incredible day. I really enjoyed the tour here at ViewRail. Len, let's close out by telling people how they can get a hold of you guys and get pricing or talk to somebody on your team.
The best thing to do is to go to ViewRail.com and get some inspiration. And once you got some inspiration, got an idea what direction you want to go, then we have a couple of questions, fill out a form, and then a sales professional and a designer can get with you and help really channel and craft that project. And they're going to end with giving you a firm price on your project.
That's really cool. Len, incredible tour today. I got to say, having taken this company 20 years ago from your garage and an online stairsupply.com, which you still can buy from stairsupply.com, to this organization now that you've built where raw aluminum, raw wood, raw steel comes in, and then this finished, beautiful powder-coated product goes out that I can install myself as a builder or that can get installed for me by your pros. Super impressive. Big thanks to ViewRail for sponsoring today's video, guys. For more information, I'll have links to everything we talked about today. And if you're not currently a subscriber, guys, hit that subscribe button below. You know we've got new content every Tuesday and every Friday. Follow me on Twitter or Instagram, otherwise we'll see you next time on The Build Show.